What is SUI? A new smart contract platform attracting enormous interest. One of the most frequently addressed issues with cryptocurrencies is the ability to scale to 1 billion users. Currently, the most popular solutions have not yet achieved true mass adoption, and many of them already struggle with fast and inexpensive transaction processing in large quantities. SUI is one of the new solutions aiming to overcome the problems of today's chains and introduce a blockchain ready for mass adoption. In January of this year, Meta, Facebook, announced that it was discontinuing its work on Dion, a blockchain project whose ownership rights and other assets were to be sold to Silvergate Capital for $200 million. Many people who had been working on crypto solutions at Meta for years decided to leave the company and start their own startups to build blockchain projects. Several companies have emerged, with former Facebook employees forming their core. One of them, although founded a few months before the failure of Dion, is the discussed SUI. SUI is a smart contract platform that has no theoretical limit on transaction processing capabilities. It offers fast and cheap transfers through parallel execution of operations, utilizes a proof-of-stake consensus mechanism, and employs a DAG structure. The programming language used for writing smart contracts is Move, developed by Facebook, which has been slightly modified for SUI's needs. SUI allows the creation of advanced applications that essentially have no limitations. From simple DeFi solutions to dynamic NFTs and games where items are fully stored on-chain and can evolve, example, through crafting. The native currency of the network will be the SUI token with a limited supply set at 10 billion. The project is being developed by Miston Labs, founded by former Meta employees. Co-founders Evan Chen, Sam Blackshear, Adeniyi Biden, George Denizis, and Kostas Chorkias previously worked together at Novi Financial Meta to help develop the Dion blockchain and the secure Move programming language. They transferred their experience, skills, and work to SUI. As evidence of popularity, at least among VCs, Miston Labs and the SUI project have successfully raised $336 million from the majority of top cryptocurrency investors. The first funding round took place in 2021, resulting in $36 million raised, while the second round, concluded on September 8, amounted to $300 million. It's worth noting that the mainnet, the official SUI network, is not yet operational, and the cryptocurrency is not traded on exchanges at the time of writing the article. How does SUI work and what sets it apart? As a new first-layer project in the market, SUI follows the trend of other emerging blockchains and is quite complex but employs an interesting and distinctive approach to building a smart contract platform. We won't delve too deeply into technicalities that are not necessary for potential use of SUI, but we need to learn a little about its capabilities and operation. However, don't worry, we won't go too deep. The possibilities of the SUI platform are vast thanks to its data model approach based on objects. An object is the fundamental unit of data storage in SUI. Tokens, NFTs, or any smart contracts in SUI are objects, and almost each of them has an owner, which can be an address or another object. There are also immutable objects without an owner and shared objects. In other blockchains, every object or smart contract is shared. In SUI, developers can freely choose or combine different types of objects. Transactions in SUI use existing objects as input data and then read, write, or modify them, creating new objects as output data. Each transaction in SUI has at least one input, which is an object responsible for covering. Let's go back to transaction types. Simple transactions are regular value transfers but also include many other operations that are not dependent on others, such as minting NFTs. In this case, SUI abandons global consensus and instead uses a simpler protocol that allows for fast, cheap, and parallel processing of even hundreds of thousands of transactions per second. Why? SUI assumes that the majority of transactions will be simple, so it optimizes them by allowing independent operations to be processed in parallel. For example, if I send a transaction to address B and you send a transaction to address C, our operations are not dependent on each other, and it doesn't matter which one gets processed a second earlier. However, when we exchange the same tokens on an exchange, the order matters and then the transaction is treated as complex. In the case of complex transactions, such as shared objects across the network where transactions need to be ordered, smart contracts, for example, a mentioned DEX exchange in which more than one user can modify them, SUI completely orders all transactions using a consensus called NAWL and Bullshark, which is based on a DAG. NAWL is the mempool protocol that ensures the availability of data sent to the consensus, and Bullshark handles the agreement on the specific order of that data. The consensus in SUI, similar to many others, functions as long as 2/3 of the nodes are honest. A DAG is a data structure that in the SUI chain is not a chain, but takes the form of a more intricate acyclic graph. Validators in SUI collaborate in creating a graph of transaction groups called collections, read as blocks. The vertices of the graph consist of certified collections, which are transactions approved by validators. Therefore, SUI does not have a linear chain of blocks like Bitcoin or Ethereum but rather assumes a graph structure. The mentioned validators, which are nodes in the SUI network responsible for network security, are chosen to actively participate in the network every day, every epoch, which is approximately 24 hours in the case of SUI based on their stake, i.e., the number of SUI tokens they hold and have been delegated by users. Active validators are rewarded proportionally to their stake. Rewards come from transaction fees, the storage fund, and initially from incentives. As the team states, SUI is currently the only blockchain that can scale with the development of Web3 while achieving industry-leading performance, cost, programmability, and usability. The key features of SUI's operation are theoretically unlimited scalability and instant transaction processing, low costs, secure programming language, ability to create rich and composable resources, improved user experience for Web3 applications, data storage. In addition to separating regular transactions from the global consensus layer using DAG and other interesting alternative approaches, SUI also employs a system of splitting fees into two parts, transaction fees and data storage fees. Validators in other networks typically have to, usually, possess a full copy of the blockchain, which includes all the data that has ever entered the network. This means they also have to hold data that entered the network before they were part of it and did not earn from adding it. SUI adopts a model that is somewhat similar to Arweave, where we pay a fee for adding data, which goes into a special fund that provides a steady income for validators in exchange not only for processing transactions but also for storing all the data. SUI redistributes the storage fees from previous transactions to future validators. Additionally, data storage capabilities have the potential to scale horizontally, similar to bandwidth. This allows developers to cheaply store data on-chain instead of using off-chain intermediaries that reduce otherwise very high costs. How does the data storage fund work? A portion of the fee paid by the user is collected for data storage and deposited into the storage fund, which covers the costs of both current and future validators. However, the fund does not directly serve to pay rewards, as it is designed never to be depleted. Rewards are paid from the profit generated by the fund through staking. The POS SUI mechanism calculates the total stake as the sum of delegated tokens plus SUI deposited in the fund. As a result, the storage fund receives a proportional share of the overall staking rewards. What's even more interesting is that users can remove data from the network in exchange for discounts. Removing data results in a partial refund of the originally paid storage fees. The option to remove data does not imply erasing the user's entire activity, such as transactions, which are immutable and final, but rather the object data, such as NFT metadata. A key property of the discount feature is that the discount is always lower than the initial fee. This mechanism ensures that the storage fund never runs out and its size changes with the amount of data stored in the network. Cryptocurrency SUI. The native token of the network is SUI. Its main tasks include covering the mentioned transaction fees, including storage fees, ensuring network security in the POS mechanism, managing on-chain operations, and serving as the primary unit of exchange within the network. With a limited supply of 10 billion tokens and pseudo-deflationary mechanisms, as I called them, SUI can also serve as a store of value, according to some. One such mechanism is the aforementioned inclusion of a portion of fees in the storage fund, which, with a large amount of data, may result in the removal from circulation of a significant percentage of tokens. Unfortunately, the distribution of tokens and details regarding incentives, such as initial inflation, which will likely be high but limited, are not yet known. The popularity of the SUI project among VCs and the amount of funds raised may lead to SUI becoming a highly centralized project in terms of supply. Miston Labs and a distinguished group of investors will undoubtedly acquire a significant portion of the tokens. Once the details of distribution and vesting are available, the article will be updated. SUI cons. SUI seems to be a project aware of its limitations and shortcomings, which are mentioned in the official documentation and which you should definitely know. First of all, SUI is a very complex project that requires two consensus protocols, one based on Byzantine consistent broadcast to handle simple transactions and the other to handle transactions with shared objects. This can cause all sorts of problems. Another downside to allowing simple transactions is that the sender can only send one at a time, requiring fast processing. Fortunately, at least in theory, it shouldn't be a problem. From myself, I could add a flaw that we cannot be sure of yet, namely the aforementioned distribution of tokens. I believe that with such huge funding, it may turn out that SUI will be a VC token. It's not necessarily impossible to make money because many projects didn't mind it, but vesting for the team, foundation, and VC can mean huge inflation for years. And the most important disadvantage is that the design does not work. Mainnet is not yet on the market, and such innovative and complicated solutions in practice may end differently. Summary: the disadvantages do not change the fact that it is a very interesting project, with a large budget for incentives and building the ecosystem, huge opportunities thanks to the approach used, and interesting tokenomics, although mainly interesting thanks to the storage fund. Practice, however, will show whether there will be anything more to it. Remember that everything looks interesting on paper. Well, not everything, but the verification of many potential gems can be brutal. SUI is a project worth getting to know without getting discouraged by reading through the complex concepts explained by the team, because their general approach is quite simple. Transactions are fast and cheap, and the possibilities are huge. Will anything come of it?